Module 1, Lesson 10, True-False Equations, there's going to be one instructional outcome that we're going to examine in this particular lesson, and it is to understand that an equation itself is a statement of equality between two separate expressions. So when class starts, for example 1, the teacher brings up this notion of the President of the United States is a United States citizen. And so there's a few questions that we want the students to think about here. Is one, is the statement a grammatically correct sentence? 2, what is the subject of the sentence? What is the verb of the sentence? And what is the object of the sentence? And then finally, is the sentence true? So this one is usually picked first. It's non-mathematical, and it allows the students to relate to it. And so in this idea, is it grammatically correct? Yes. What is the subject of the sentence? And that's what we want the students to identify, is that we are talking about the President of the United States. This is our subject. What is the verb of the sentence? Most students will quickly point that out, that it's the word is. And then finally, what is the object of the sentence? And that's a United States citizen. And so then we finally ask, is the sentence true? And all the students say yes. You know, the President of the United States is a citizen of the United States. And so with that being stated, we bring in this idea here, is what about this statement in part B? The President of France is a United States citizen. And so then we'll go through the same thing. Is it grammatically correct? The students will answer yes or no. What is the subject? The students will say the President of France. What is the verb? Again, they will say, well, that's the is. And then the object is United States citizen. We'll ask them, well, is that true? And then they look around and they think, you know, kind of silly like. And then they'll respond, and the answer is no. Obviously, the President of France is not a United States citizen. He is a citizen of France. And so we take this notion or this idea non-mathematically, and we continue with example 1, and we bring in part C, which is a mathematical statement. And so we're asking, what is the verb, what is the subject, and then what is the object, and what is the sentence true? So in this case, in the application, what is the verb of the sentence? We want the students to identify that the equal sign is synonymous with is, from what we talked about in our previous example. So that's our verb. What is the subject of the sentence? That would be the 2 plus the 3. And what is the object of the sentence? That is the 1 plus the 4. And so the question comes up, is the sentence true? So the students, well, in their mind, they think, well, 2 plus 3 is 5. And then we have 1 plus 4, and that's also equal to 5. And so the students will always respond to that is true. So we bring up another statement, mathematical of course, where it says 2 plus 3 equals 9 plus 4. And just to make sure the students get it, you know, the teacher may call on a couple of students and ask, what is the verb? They would again say that's the equal sign. What is the subject? They'll say that is the 2 plus the 3. And what is the object? That is the 9 plus the 4. And so they'll ask, well, is this statement true? And so they'll say, well, if we take 2 plus 3, that's equal to 5. And if we take 9 plus 4, that's equal to 13. And so then they'll write equals 13. And more often than not, someone's going to say real quick, wait a minute, 5 does not equal 13. And so since 5 does not actually equal 13, then we'll say that this statement is false. This is going to be the main conversation and the main topic out of this particular lesson. So what the students then experience in class is this idea or this concept of what a number sentence is. And so it's a statement of equality between two separate numerical expressions. A number sentence is said to be true if both numerical expressions are equivalent. In other words, they evaluate to equal the same number. It is said to be false otherwise. True and false are called truth values. So what you're going to see is a series of true and false potential statements. So the students will look at it and they will say, well, if I've got 4 plus 8, that is equal to 12. And if I've got 10 plus 5, that is equal to 15. And so we ask the students to evaluate whether that is true or whether that is false. And they're going to say that that statement is false. So the teacher will then give students an opportunity to look and think and decide, what about the 1/2 plus the 5/8 equals the 1.2 minus the 0.075. After a few minutes and discussions, the students will come up with a decision, and this decision here will be true. There will be 4 more on this slide. For example, number 2, the students will go through, they will evaluate each one as either true or false. We want the students to try this on their own, compare it with a partner working in pairs, and then they will come back as a whole group to make a decision. So if you are watching this video, take a moment, and I would recommend you pause it, see if you can predict or determine mathematically whether each one will be true or false. In this first one, this will end up being true. In the next one, it will also be true. For the 7 plus 9 squared equals the 7 squared plus 9 squared, that's going to be false. And for pi equaling 3.141, that will be false. There are actually more digits. Pi is irrational and continues from there. Here are 4 more that I encourage you to try by pausing the video, making your predictions first, and then of course again press play and see how well that turned out for you. But in K, that would be false. In letter L, that would also be false. For 1/2 plus 1/3 equals 2/6, that will also be false. And then 1/2 plus 1/3 equals 5/6, that will be true. If you do need help solving any of these mathematically, please contact your child's teacher and they will be more than happy to walk you through the summation of each of these expressions. And so if we look at this one, 4 more, final 4. So this one will be false. This one here, the next one, will be true. And then we'll round out with a false and then a true. So that sums up lesson 10, all about whether an expression on the left and an expression on the right is equivalent to the same value, or whether basically that numerical sentence is true or false.